Finding composite functions. Often, when we have composite functions or nested functions, where there's a function within a function, we're not looking for a numeric answer. What we're also looking for is what is the overall equation to determine the final answer. And what we're doing here is we're going to actually determine it, because it could be any answer, but we find an equation overall of what it's going to be. And we're still using nested functions, but we're going to see what the final variables would turn out being. I've got right here f of g of x, and g is being the nested function, is the inner function, and the f of x is the outer function. Remember, this can also be written as f open circle g of x. Again, the inner function, the nested function, is the g of x, as denoted in both these versions. And all we're really going to do is try to determine, for any x, what is the final outcome in terms of variables of a composite function. And as I said, this is the outer function right here. F of x equals square root of x squared minus 1. So what we're going to do is every time we see x, we're going to replace it with this g of x right here, which is what I've done here. Now that's x squared, so it'd be g of x squared minus 1. And we're going to take our g of x, which is x over 1 plus x, and again, I said every time I see an x in the f of x, I replace it. So instead of x squared minus 1, it's going to be x over 1 plus x squared minus 1. That is the final nested function. I could go backwards with this as well. What I mean by that is, let's suppose my nested function is g of f of x, right here. And that means my outer function is the g of x, which is x over 1 plus x. And every time I see an x in my outer function, I'm going to put in my entire equation for the inner function. And the inner function in this case, g of f of x, is square root of x squared minus 1. So every time I see an x in the outer function, I'm replace it with square root of x squared minus 1. And in this case, the x over 1 plus x, it'd be square root of x squared minus 1 in the numerator, and 1 plus square root of x squared minus 1 in the denominator. And that's it. Let's look at this nested function right here. F of x equals 6 minus 1 half x. H of x equals 4 times x minus 3 squared. Find f of h of x. So h of x is the nested function. That means every time I see an x here in the outer function, which is the f of x, I'm going to put this entire equation within that. And like I said, which is the h of x, that is 6 minus 1 half, right here, h of x now. Instead of 1 half x, it's the h of x. And we're going to put that right here. So, it's 6 minus 1 half. What's that equation? 4 minus x minus 3 squared. Right there. Now, I can simplify this, which I'll do here. But actually, the final answer would be correct by just putting it like this. But let's multiply this out here. This is 6 minus 4 minus times x minus 3 squared over 2. This crosses off. 4 over 2 is 2. And I'd simply write it as f of h of x equals 6 minus 2 times x minus 3 squared. I'm not going to FOIL that x minus 3 squared. This is good enough for what we're looking for. And it's also correct. Here's another one here. F of x equals 8x cubed minus 5 right here. H of x equals cube root of x minus 5. Find h of f of x. This is the inner function. The f is. So that means every time I see an x in the outer function, which is h of x, which is right here, I'm going to replace it with 8x cubed plus 5. So my outer function is cube root of x minus 5, and I'm going to put in the inner function here, which is the f of x, which is all I've done here. What's the f of x? 8x cubed plus 5. Now this is interesting here, because this is a cube root of 8x cubed plus 5. The reason it's interesting is 8x cubed plus 5 minus 5 from the original equation leaves it to be, now 5 minus 5 cancel out, and we're left with 8x cubed. Well, the cube root of that is 2x, because 2x times 2x is 4x squared, times another 2x is 8x cubed. So, the h of f of x is simply 2x. G of x equals 9x minus 2. H of x equals 3x squared plus 2x. Find h of g of x. Well, there, my g is my inner function, my nested function. And every time I see an x in the outer function, which is the h, I'm going to replace that with 9x minus 2. So, what we're looking at here, oh no, I've got this backwards. Let's fix this. I think I said it backwards. Nope, I said it right. I'm sorry. So, h of x is my outer function. It's 3x squared plus 2x. And every time I see an x, I replace with 9x minus 2 with that g of x. So instead of 3x squared, it'd be 3g of x squared plus, instead of 2 of x, 2 of g of x. Now I'm going to put in 9x squared minus 2, 3 times 9x squared minus 2, plus 2 times 9x minus 2. Now what I've done here is I have foiled that 9x minus 2 squared, which ends up being 81x squared minus 36x plus 4, still times 3 outside of the parentheses, plus 2 times 9x is 18x, 2 times negative 2 is negative 4. That ends up being 3 times 81x squared is 243x squared, 3 times negative 36x is minus 108x, 3 times 4 is 12, minus 18x minus 4. Well, if I look at this, 243x squared, that lays by itself. Minus 108x plus 18x is minus 90x. And then I've got, right here, minus 4 plus 12, which is 8. So, h of g of x is 243x squared minus 90x plus 8. Now, real-life examples of composite functions. One is the Spanish flu. Between 1918 and 1920, over 50 million people died. In fact, so many people died on both sides of the First World War that is why the war basically stopped. Over 500 million people were infected with it. And 25 million the first 25 weeks alone, the first half of the year. So, the death rate and the infection rate were composite functions because the death rate is a subsidiary of the infection rate. You have to be, to die, no one wants to die, but if you die from Spanish flu, first you have to be infected. The equation for the death rate was 1.2 to the x plus 60x, where x number of months Spanish flu since the initial infection. The infection rate was 133x plus 19, and that's per 10,000 square feet in living space. In other words, 100 feet times 100 feet. So, if my death rate, my infection rate, d of I of x, death rate is the outer function, and every time I see an x, I'd replace that with I, which is the infection rate, which is the inner function here. And I said the inner function is 133x plus 19. So, the final equation would be 1.2 to the 1.33x plus 190 plus 60 times my infection rate, 1.33x plus 190, And when I multiply this all out, it ends up being 1.2 times 1.33x plus 190 plus 79.8x plus 190 right here. And the whole point of showing you this slide is, I know there's some exponents here, but really we're saying there are different rates going on. And if we can figure out the infection rate, we can figure out the death rate, and vice versa as well. This is an example of the Spanish flu, and here's the equation for it right here. How many people got sick so quickly? They actually had to set up in like large gymnasiums and factories individual hospital beds for these people. And we had during MASS during COVID, where unfortunately 6 million people died, but we lost at least 50 million people worldwide from COVID. From the Spanish flu.